Welcome to Social Distillation, the submarine still of the internet, where we attempt to drop the bead and pour white lightning straight onto your brain. Today's white lightning will be lots of witchcraft.
Yes. So we've kind of teased this one. We ended up doing program density last time, but we wanted to talk about what's called bioenergetics, which is how your body uses energy and produces energy. Because it kind of gives a backdrop when we do, when we start to discuss things like high intensity training versus aerobic training, log steady state training, versus sets and reps and how much rest in between and things like that. So it's kind of like the chemical backdrop to go with that.
This is when we talk about the different types of goal, cardio, endurance, strength, power, blah, blah, blah. Okay, when we use all those terms, I like the way you phrase it, the backdrop for that. It's ultimately what you're doing is manipulating these energy systems. Is you have to know, even if you don't know all the witchcraft, you need to know at least the basics so that you can make sure you're optimally manipulating these energy systems to get the specific results you're after.
Well, and just to kind of open up with something a little lighter, I keep saying when you learn physics, you hate action movies. Well, when you learn biochemistry, you hate the Matrix. Because we would be horrible batteries. We would be negative energy batteries for these AI robots. They would drain within a week of using us as batteries. Plants are your creating energy battery. They take solar energy and form bonds. So energy is stored in that bond. Then we eat it and we break those bonds and we use it as energy. And there's so many, there's less efficient and more efficient ways that we do that, but the less efficient also allows us to do things that you couldn't do with the efficient source. So as we break these down, we would be horrible batteries. That's just the main, the gist of it. They would be doing whatever it took to plant trees. I know they said the sun didn't shine on them anymore, but it just, the whole Matrix movie wouldn't work once you understand this, especially since we shit out half of our energy that we ingest as well. So so you'll never watch Matrix the same again. So the main thing I'm going to bring up kind of
that's okay. From what I hear, they ruined it themselves with the fourth one.
Well, that's just the wokeism. But okay, so this is kind of my notes I go by, but I like the picture on here. So we got the base source of energy. Everybody thinks of carbohydrates or proteins or fats or anything. Well, at the end of the day, all energy in the body is adenosine triphosphate. Say that 3 times fast. ATP for short. All right. And so there's your chemical makeup of it. And right there is a very, very high energy bond. That chemical bond connecting that last phosphate on there. So all energy in the body ultimately is a breaking of that bond to release energy to do whatever action we're going for. So just wanted to bring that picture there as we go into it. So when we talk the energy systems of the body, it is the different ways of creating that ATP molecule that in turn shuttles to where it needs to go to do the action and that needs to be done. So one important point ahead of time is all energy systems are working all the time. It's just which ones are dominating and which actions and what ratio you have to do that. And so the quickest one is the creatine phosphate system. Another thing about this little lecture here is as you hear some of these chemicals and terms, you can start thinking in your mind about supplements. Why would a supplement work for me when it comes to something like that? And one popular one is creatine, right? And so this is the backdrop of how creatine may work in the body. And the evidence seems to suggest it does help to some degree if you dose it properly. But the most immediate energy source is creatine phosphate. It is basically a phosphate attached to a creatine, and it shoots that phosphate to an empty ADP, which is the one without the third energy bond on it. So diphosphate, triphosphate, diphosphate. Once that energy is used, that bond is broken, that ADP floats around and is looking for another phosphate to pop on there. And the energy systems are where you get that those phosphates from. So creatine phosphate, it's a direct link. That creatine is a weaker bond than that ADP it has it at the end. So that phosphate hops over. And so that's the immediate source. And we're constantly using that. And just to snap the fingers, it was the dominant source because it's there. It's ready to use. Glycolysis is the second one. That's a little bit slower than the creatine phosphate, but it kicks in faster than the aerobic system. All right. So but it's not as efficient. So we'll break down the cycles as we go into detail about each one, but it is slower than the direct energy, but it is faster than aerobic system. Then we got our aerobic system, which is the most efficient of them all. It's the geometro of our systems, right? It uses like a drop of gas to go a long way.
Yeah, and that's what I was prefacing with this, is that this is why I'm leery of the term cardio. When people say, well, what do you think about cardio? Okay, well, it depends. What do you mean by cardio and what are you trying to achieve? Because what most people think of is a steady state, go for a jog. Okay, but as you're pointing out, that's your most efficient system. That means for most of us, for most of our goals, which is look better naked, that's not going to be very good.
Mm-hmm.
You've got to manipulate it. And you've touched on this in the past, is that for most people, the point of cardio is to improve that cardiovascular system, that cardiovascular endurance, so that you can do your other work at a higher level.
Well, and we'll get more into detail on this, but the aerobic system is one you need to keep up because it reduces recovery time, because it is the primary recovery mechanism from these other systems going through. So we'll look at the time frames on that. We're looking at from the creatine phosphate system. Usually that's your 1 to 10 second range. So Usain Bolt running 100-meter dash, he's basically just depleting that system because it's the only thing that works fast enough. From that 10-second to 3-minute range, you're dominating. Again, this is all based on intensity. You're dominated by that glycolytic cycle. So, and again, we'll go into the substrates and stuff. And then from that 3 minutes beyond, you're dominated by that aerobic system. Now, the aerobic system is the slowest acting. So that's why we warm up. It's one of the reasons we warm up, is because we're trying to get that thing kicked in. So when we do our sets and reps, we're recovering between faster because that system's already ramped up and creating a high amount of energy. So again, they all work all the time, but we want to shift the range of which are dominant. So if you're doing a set of 20 reps on a squat, that's going to take about a minute to get through that set. You're going to be mostly dominated by the glycolytic system. Sorry, someone started. I might have to do a scheduling text here in a second, but I might have to pause this. Where was I? The time frames?
Time frames.
Yeah. Okay. So again, quickest action, creatine phosphate, up to 10 seconds of, and this is the intensity, not you just did something for 10 seconds. If you walk for 10 seconds, you're not kicking that you're not depleting that to full effect.
Yeah, you can start walking and you can maintain that pace for hours. You start sprinting, and there's a reason why Usain Bolt doesn't run the 400 in 36 seconds, because that's not how it works. There's a reason there's a drop off there.
This is the intensity of the action. I guess hear this as in me saying you can do this action for up to 10 seconds. You're dominated by the creatine phosphate system. You can do this action in a range between 30 seconds and 3 minutes, and maintain the intensity. Then you're going to be dominated by that glycolytic system. And then you can do this for an extended period of time beyond that. Then you're going to be dominated by the aerobic system. And if you start too fast, that's why you don't hit your steady pace right off the bat when you go out for a jog. Like say you want to jog for 30 minutes, you don't start too fast, or else you don't ramp that. You get ahead of your energy supplies. You need that glycolytic system to not be depleted while your aerobic system is kind of kicking into gear and ramping up its production. So creatine phosphate is pretty simple. I don't think we need to go into too much detail there. It is exactly what I said. That phosphate jumps to the ADP. You got a new ATP that is used for energy. Then the glycolysis is a little bit more complicated. And by a little bit more complicated, let me bring up this slide here. All right, now this is slow glycolysis. I'm not going to go into the difference between fast glycolysis and slow glycolysis.
Oh God, the Krebs cycle, no.
Yeah, the Krebs cycle. Everybody loves the Krebs cycle. So we've got a lot more chemical processes, and it all starts with a glucose or a glycogen molecule being broken down into pyruvic acid. And then it goes into the Krebs cycle, and we've got a lot of enzymes. We don't need to memorize them all. And at the end of the day, this little guy pops out the bottom, and you net 2 of those at the end of the day. So it's not a big net gain for what you're doing there. But again, takes a little longer, but it's more than just one. It's more than that creatine just popping out one. So now you're actually replenishing your ATP supplies for use with glycogen or glucose molecules. All right, so sugars. Oh, where are we at? Oh, here we go. Sorry, brain fart on how to use Zoom. Okay, so one quickly when you need it. Couple at a time, breaking down sugars. It takes a little bit longer, but it's still relatively quick. The chemical reactions that happen in your body are so fast. It's unbelievable. We can't even appreciate how fast that happens. And then we go into aerobic metabolism. So now we're talking the electron transport chain. So aerobic, it's a long process. You could start with a fat, and then it breaks it down into fatty acids, and then breaks it down into this and oxidation. It oxidates the fat. So we need oxygen for the aerobic cycle. The other two are anaerobic. We don't need extra oxygen for it. The aerobic cycle, we need extra oxygen because we need it to oxidate or break down the fats. And then we need it as the electron receptor in the electron transport chain, which ultimately pops out, I think it's 32 ATP, and I should have checked my notes. But at the end of the day, it takes a little bit longer, but 38 from one glucose molecule is your yield from that electron transport chain. So 3 different systems. Glucose or glycogen molecules are what's ultimately broken down as we go. Do you want to put in questions before I go into other detail?
From a practical example to illustrate what you're talking about here, so that creatine energy system, so you're talking about what we're talking about here to illustrate is if you do a box jump, okay, that is a lot of intensity very quickly, and then it's done. Okay, so that's the system you're using there. That's why, you can see JJ Watt jump on top of a fridge, good for him. But if you were doing like a set of box jumps, you wouldn't do that. That's why you do something lower, because you get that big burst of energy right off, but you can't maintain that, right? You would have to bring that down if you were going to do, say, 10 reps of box jumps. And that's when you're engaging that next energy system. That's when it becomes more dominant. So if you're doing, if you're doing like a 1 or 3 rep max of a lift, that's quick. But then when you keep going, when you get into that more, 10, 12 rep kind of thing, now we're engaging this next energy system, or this energy system is becoming more dominant. And then the next energy system becomes more dominant. And that's, we're going down the chain here. Do you have the, where's my CS book? I think the CS book kind of, doesn't it have a picture of it where it's all in a big circle of starting with the creatine and how it.
Let me grab mine real quick.
Okay, I didn't know if you had that in your notes. But that,
Okay.
it's important to keep in mind when you start to get into the practical application of this, and that's why I like that.
And the source here is Essentials in Strength and Conditioning from the National Strength and Conditioning Association. Probably have to use the index to find it fast. Oh.
This is the textbook for what is the highest level certification in strength and conditioning. If you've got somebody at the professional level, an NFL's head strength and conditioning coach is going to have this certification along with other stuff. But this is the biggie.
Yeah, this is the CS stands for Certified Strength and Conditioning Specialist. I think I got the right spot here. I'm not seeing a big. Oof, that's a complicated graph. So that's good. Okay, I already showed you that one. Krebs cycle. Now you might be thinking of a different textbook.
Maybe
because it doesn't have at least what you're talking about. But yeah, again, it's the intensity of the action, and which we're going to use time as how long you can maintain that intensity determines where the shift is and what you're going for. I guess let's take a step back and talk about energy sources themselves. So,
oh yeah, that was my next thought, because you were talking about oxidation and glycogen. This gets into the background nerdery of why sugars are bad. Yeah, for when you're you are trying to lose fat, lose weight.
Remember, there are no demons. It's just how much we eat and when we do it and how our activity levels are. Because we'll talk about our first energy source, carbohydrates, right? It's the only energy source for glycolysis. So you need carbohydrates for glycolysis. Now, that doesn't mean you need to ingest only a lot of carbohydrates. That your body will create them out of other things. But
there's a reason they're called simple sugars, because the molecule is simple, especially compared to, like, if you look at an illustration of a fat molecule, it's simple, therefore it's easy to break down.
Yeah. So as the intensity of your activity increases, so we're talking about anaerobic activity, then the greater percentage of energy comes from carbon, hydrogen, oxygen together as a glucose or a glycogen molecule, right? The important it's when you're really working with athletes, that's kind of why it's important, why you do have them ingest carbohydrates, because they're doing a lot of high intensity activity and they're probably doing it often. So we need the fastest way to replenish that, which is directly from eating carbohydrates. In a short-term anaerobic kind of state, you're going to use about 60% of your glycogen stores, and that's stored in the muscles. It's some of it in the bloodstream and some of it is stored in the liver. So
if you've heard the term carb loading, this is where it comes from, and this is what they're talking about.
And if you deplete that much of your glycogen stores, it could take approximately 24 hours to replenish that, even if you have a good steady diet. Which, when we're talking training, now we talk training frequency. So if you're in an anaerobic state without doing a lot of muscle damage, you can train about every 24 hours on that because you can replenish your glycogen stores, your energy stores. Then we've got the second energy source, fats, right? So we got triglycerides that are broken down to form free fatty acids, and they're released in the blood where they can enter the mitochondria in your cell, so that everybody hears about the powerhouse of the cell, this mitochondria. It's called the powerhouse of the cell because it is the spot that we do our aerobic oxidation. And then it forms other chemicals, like, I'm not going to go in too deep of a breakdown of that, but when I showed you that graph of the Krebs cycle, acetyl-CoA was one of the substrates that go in there. That's formed from the fatty acids as well. And so that can be used once it's broken down. It can be used in either the aerobic system or in the anaerobic system. So we use it for both, but it has to be completely broken down first. Good thing or bad thing is it takes a while when we talk about how these systems work. So it's inefficient when it comes to explosion or being able to do an action quickly. So if the lion jumps out of the bushes, it's not, you want some stored sugars in your body because you're going to need those to run away from it, not that fat that's being oxidized.
This is what's going on in the background. This is the nerdy witchcraft of, we've mentioned the term afterburn before.
Well, I'm going to get to that.
Okay.
I'm going to get to that because we also talked about Usain Bolt, and I should have queued up a video or something. I don't know if we could use it, but I should have queued up a video of him interviewing after a race. So that it's inefficient from a timing standpoint, because it's not going to be great for a quick explosion when you need it, but it is very efficient from an energy standpoint, because that one fatty acid, see if I got a picture of a fatty acid, that one fatty acid is many glucose molecules when it's all broken down. So think of a fat as basically, it's shaped a little different, but your body takes care of that. Think of it as a bunch of chained together carbohydrates, and then they chain together with themselves and they store in your body. But it is many glucose molecules, which can be then later used for a lot of energy in that aerobic system. So it's inefficient from a speed standpoint, but it's very efficient from an energy production standpoint. There's a lot of stored energy in our bodies, in our fat cells.
As an illustration, I've mentioned that I'm a big dork and I like to unwind at night by watching nature documentaries. So I know fun random facts, like a polar bear can go for like 3 to 4 months without eating. Because during the summer, its food sources are mainly seals and they're not there. So while there's no pack ice, it can go 3 to 4 months without eating. It can do that because it stores so much fat when it is binging, because there's that much energy within that one fat molecule, and it's got a lot of them. That's how these animals can do that.
A good human example of that is, it was and this is when I was researching fasting in general, but it was an example of this, of how we can survive without, the whole, you're going to waste away if you don't eat every 3 hours. That works for some people. There is no demon strategy, as well as there's no demon food. If you're comfortable every 3 hours eating and you can stay within your calories, go for it. If you don't like to eat all the time, or you have trouble not overeating if you're eating all the time, maybe fasting is for you. I'm a big eater, so it's for me.
Yeah,
I just eat less often. But in that research, I derailed there. In that research, I came across a British case study where there was a man. He was kind of one of those, you'd see him on the 600-pound journey or whatever shows, and for a whole year, he never ingested anything but intravenous vitamins and minerals, and they gave him amino acids in his IV.
Wow.
He did not eat for a year, and his body subsided on his own fat stores, and they were supplementing the micronutrients you need plus amino acids, so that way his body doesn't is encouraged to not waste any of its muscle mass. So, and he lost a lot of that 600 pounds, a good to where he was almost a normal weight. By not eating for a year. He lived off his fat stores. It's a lot of energy. A good example too, a gram of fat is 9 calories, right? A gram of carbohydrate is 4 calories. So you get a lot more energy from that gram of fat. And because you're typically in an aerobic state, you get 38 ATP out of that, the glucose that's created from that, rather than the 2. So we're talking a very efficient energy source, which is one reason it's hard to lose fat, because a little bit goes a long way, right? So we got fat as the second energy source, and then protein. You can use it in your body, but it's incredibly wasteful. Everybody's like, oh, you're going to eat all your muscle away. Your body will use all means necessary to use the glucose and fats before it breaks protein down into glucose. Now it does that through a process called gluconeogenesis, and the amino acids are broken down into glucose. But not only is it inefficient because it's hard for your body to do, it has to shuttle the protein to the liver. Almost everything happens in your liver, by the way. So liver is the most awesome organ in the body other than the brain. But not only is it hard to do because it has to go through that big expensive process, but then there's also waste products. The 2 main waste products being urea and ammonia, which floating around inside you are not that good. So we've got those 3 energy sources. And then again, we went through the timing. We'll call it 1 to 30 seconds for the first one, 30 seconds to 2 to 3 minutes, and then beyond that for the oxidative. Did you want to go anywhere with that before I go into talking about the structure of workouts and stuff and how it?
Well, I don't know what your notes are on your lecture. Did you want to talk more about the aerobic system and how that works when you go past that that anaerobic energy system, and then what becomes dominant there? I don't know how nerdy we want to get to make the point of how efficient the aerobic system is, therefore how inefficient it is for most people's fitness goals.
Let's go into the workouts, because
Okay.
I think that's going to be clear.
Okay.
From the example model. So let's start with the first part of a workout, is warm up, right? So warm up, the goals of the warm up are to increase body temperature. That's why it's called a warm up. It's the most important part of the warm up, to go through the ranges of motion you're going to be training in. So that way your body's, your stretch reflexes is in a position where it's not going to overreact and you're not going to hurt yourself. So we've got activity to warm the body temperature up. We're increasing blood flow. We're going through full range of motion. But the other part of it is when you do those 3 things for a little bit of time, your aerobic system is ramping up because you're already using energy to a greater degree than you do in your normal daily life, right? So,
yeah, I was going to use the term priming the pump, but how many people even know what that means anymore?
Okay. Get me back on topic, but I got to derail for a second. So we will know it for much longer. And this is why I don't like this jump to electric cars. But so I have all my household tools. I switched to DeWalt battery operated, except for my my lawnmower. That's still a gas powered lawnmower. But I've been switching to the battery and everything uniform, so that way I can just use the same battery packs and switch everything around. Well, one of the things is a chainsaw. And when I had to take down my little lemon tree after the freeze, it worked great. I was awesome. So I took it to my mom's, like, this is going to be great. I'll just have to charge the battery every once in a while and break anyways. And 20 minutes and it was done. It didn't run out of battery. It just wouldn't work anymore. It overheated. The battery overheated. And so we still need those gas powered things in certain situations. So it's great for little around the house things or when I chop up some firewood or something, but to do a big job out in the heat, gas still won. So I still got my Husqvarna with the primer.
Well, I guess that's probably the thing that most people would have and know of priming is a gas powered lawnmower. You got to prime that, get that system ready to start flowing. Before we get back on track, I would add another one to the warm up is you got to get the lubrication flowing. Giggity.
Well, that's part of the increased blood flow.
Is
and
there,
and
there's a lubricant in your joints. That's why our if you look at Sam's warm-ups when we showed the sample workouts and the stuff I do, there's a lot of joint movement. That's part of that range of motion. You get those joints moving so that they get lubricated.
Well, we'll do a whole episode on just warming. Okay, so let's kind of stay on the energy systems. So you're ramping that up, and the key word here is homeostasis. So what you do all day long, your body just gets used to, right? And so you have an activity level that your body's used to, and it's going to find the most efficient way to go about it every day. And so when we warm up, we want to ramp our system up just above, not so much that we hurt ourselves yet, but just above that homeostasis. And so your body temperature increases again. You're going through different motions. You're using energy at a faster rate than you do in your normal life. So it's that kicks all those other systems in because your body says, oh, we've got to make up for that loss already. So they're already kicking in. And so that's where the energy systems come into the warm up. And so you want a little light intensity to get that going. And now you're setting yourself up to recover faster between exercises and basically even have more energy during the sets. So the workout itself, intensity determines everything, right? So if I'm going to train in the glycolytic level, I need to do activities that I can maintain between that 30-second and 3-minute mark. Now the 3 minutes pushing the edge already.
Yeah.
Remember when I used to do the sets of 3-minute squats? That sucks, by the way. 3 minutes straight of squats. But it really kills that glycolytic system. One of the byproducts of glycolysis is lactic acid, right? So you feel that burn in the muscles, you're building up that lactic acid. Then you know you're in the glycolytic system because you're building up that lactic acid. Now it clears faster than people think, and it is not why your muscles are sore. So
that was the most interesting part of the witchcraft to me when I started studying this stuff is, lactic acid isn't what most people think it is, isn't what we used to think it was. And so that was the most interesting part to me of all this witchcraft.
But then when you hit a steady state where you're moving at a pace that you can maintain without that burn building up, now you're kicking into that aerobic state. And so if you want to train the anaerobic system, then you would do something at an intensity, and this doesn't have to be weight training. This could be 400-meter dash. This could be something along those lines where that burn builds up and then you let it clear. And then that burn builds up and then you let it clear. And so, if you want to train in a glycolytic state, which is important, you would do something like that. If you want to train in an aerobic state, then you need to find a pace of whatever you're doing that burn doesn't build up too quickly, because you need that glycolytic state to last long enough for your aerobic system to start pumping out more energy. And so that's kind of how you can break it down there. But there's importance to training all of those systems. If I do more explosive work and maybe supplement creatine, that 1 to 10 seconds, maybe my creatine phosphate system was only good for 8 seconds when I started training. But I do that high power training more often, maybe I'm good for 10 seconds now. If you're a 100-meter sprinter, that's important. If you're a pitcher, that's important because you need to explode, recover, explode, recover, explode. So you can train these systems separately, and they're all important. Of course, we're fitness goal oriented right now because we're getting older. We're not young pups anymore, and I'm not getting paid, $1 million to throw a ball. So it's so you want to train each one to the degree that you can without any of the others suffering. Now, anaerobic system, again, you're training to that point of where you would fail within 3 minutes, and then you're trying to recover as fast as you can. And so you're training both of those. Now, double positive effect. First of all, you just get better at it, right? So that's the outside looking in effect. In the system, now we're talking about blood sugar, right? So we're talking about insulin sensitivity, because you're creating a stress that is encouraging your body to store more sugar in the muscle cells because you do that activity often. And when you do that, the membranes of the cells are going to be more sensitive to the blood, the sugar in the blood, and the insulin that shuttles it in. Insulin, for those, I guess I need to preface some things. Insulin, for those that aren't familiar with how it works, it's like the insulin receptor on the cell is like a doorman at a club, and insulin is like the promoter that can get you into any club. And if that happens too often, or there's too many promoters all the time, the doorman gets desensitized to it, and so it stops opening up for the promoter and letting in the sugar. And so then your blood sugar goes up and up and up because it's not going to where it needs to go.
Yes.
And that's just from an overstimulation standpoint. Everything becomes numb when you stimulate it too often, right?
And then you go blind. But I like that. I like that analogy, and that explains why, if you don't know the witchcraft, why there is the term blood sugar, because it's in your blood when it needs to be in your muscles or stored.
And if you do high glycogen consuming activities often, you create an environment where the system is promoted to let more into the muscle cell, where it's actually useful. In the blood, ultimately, it's going to be inflammatory if there's too much too often. But if it's in the cell, it's sitting there ready to be used by any of those systems, or not the creatine phosphate, but the glycogen system, or even the aerobic system when you're in that state. So by training in the glycolytic state, you're creating an environment that ultimately will, that will ultimately lower your blood sugar. And that's important, right? So that's why we do that kind of training quite often, because you can create that good, and it's such a big problem for most people, especially in the modern diet. Now, where you poo-pooed on sugar spikes that insulin more than pretty much anything else. So the more simple the sugar, and especially in a crystallized state, it really has that super high glycemic index, which is the rapid release of these other chemicals that respond to glucose in your system.
Especially for the average American now, who's already got a poor diet, already has a low activity rate. So you haven't been working that system to create that optimal, platform for getting that sugar into the muscle. So the more you consume, it's just going to mess with that sensitivity.
You can manipulate that, though, because so we've just sensitized the system by doing glycolytic exercise. That's why a lot of these post-workout, especially if you're in that bodybuilder mode where you're trying to get as big and as fast as possible, but they also chase the burn with their sets and reps. Most people think powerlifting and bodybuilding are the same. They're not. Bodybuilders, if they're smart, will power lift on occasion so they can get stronger in their high rep sets, but bodybuilding is about those reps and sets. It's volume. I mean, we're looking at sets of 12 and above a lot of times. So they're chasing that burn. They're chasing that glycolytic state, because then they eat something that is high in sugar and protein right afterwards. It shuttles straight to the muscles, and that's where they get that explosive pump. In fact, they will supplement. This is where they really screw themselves up, but they will supplement by injecting insulin after their workouts and then having their post-workout. And so now they're really shuttling everything into the muscles, and they're not only getting faster recovery, but they're also getting just fluid and substrates, sugars and everything in the muscles really quick. So you can manipulate that system with the simple sugars. It's just not the best idea, especially for most of us that are just trying to be a healthy weight and be, be a little stronger and stuff in the process. Now, so we're promoting the receptors to be more sensitive to sugars in the blood. So that's the benefit. And we're training to be able to handle more hard work, right? So ultimately everything's a build. If I could do 100 pounds for 8 reps, that's going to be a glycolytic state. If I train that system, I will have more ready energy in the system that maybe I can do that 100 pounds for 10 reps the next time, or 12 reps the next time. Then I've got more volume. So that's 400 extra pounds of volume load. So I did more work. And from a weight loss standpoint, that means I used more energy. And from a fitness standpoint, that means I got better at doing something, right? I got better at moving my body in some way, shape, or form with external resistance. And then the aerobic system, I don't think we need to beat dead horse on that. Again, you're getting to be super efficient. Now we need that to be also healthy, because most of our daily tasks are not high intensity. We just do them often all day long, and you can affect your fatigue levels on that. Or if you do something like gardening on the weekends or doing your lawn or whatever, you're going to get through it without being toast at the end.
Right.
Well,
this is why I beat the dead horse, and it's because I don't have to do this, and I don't know what your experience is, because you tend to train a different kind of clientele, but it's not as bad as it used to be. And this is one of the positives. We beat up CrossFit a lot, but this is one of the positives of CrossFit. It has made people less biased against strength training. And the reason I beat the dead horse of aerobic is because there are still those people who think to get in shape, air quotes, whatever that means, is I've got to get on a treadmill. I've got to, get on an aerobic, a cardio machine, and stay there for half an hour or more. And again, because the aerobic system is so efficient, that means it's paradoxically inefficient for what most people's fitness goals are. And so it's not as hard as it used to be to convince someone that no, to meet your fitness goals, the base, the core of your program needs to be strength training. But there are still a lot of people that I see in a box gym who all they do is a cardio machine, or a lot of people will do 2 or 3 different cardio machines and be in the gym for an hour and a half doing nothing but that.
Well, let's start with high intensity training and work back to cardio, because the answer when someone says, should I do cardio, should I do HIIT, should I do weight training, the answer is yes. Again, we're talking fitness now. Everybody in the audience, if you're wanting to power lift, the answer is a lot less than that when it comes to the cardio. If you want to run a marathon, the answer is a lot less than that when it comes to the strength training.
The last conversation I had on cardio was somebody who asked, what do you think about cardio? And my answer was, it depends. Why are you doing it? Are you doing it to do an aerobic activity? Are you trying to train for an aerobic activity? No, I'm just,
Well, this is the first question that should come out of any trainer's mouth when someone says, what should I be doing? The first question should be, what is your goal? All right, we can go the individual attributes after that, but what is your goal? And again, we're going to really stick to energy systems here. And now we're talking about the goal of general fitness, right? High intensity training. So I brought up Usain Bolt. And we brought up in the past what we call afterburn, right? So he sprints faster than anybody in the world for not even 10 seconds. It's for 100 meters, and it's like, what is low 9s or high 8s?
I think it's still low 9s. I was just about to look
I think
that
it
up
was
'cause
like almost under 9, but it's like right on the end. But either way, faster than anybody else in the world has ever done, or probably will do for a while. And about 3 or 4 minutes later, he's doing an interview, and he's still talking like this. Now, the aerobic system is, after it's kicked in, is your number one system for recovering all of the other energy losses, right? So your creatine phosphate is his prominent energy immediate there, but he used almost every bit of it in his body. And that aerobic system is kicking in to recover the things he used in the other systems. So the systems work together to, again, they're all working at the same time, but that aerobic system is creating those, the ATP that ultimately gets stored in that creatine phosphate system again. So it's
9.58
9.58
is his current record.
Oh God, it's so slow. But again, his aerobic system kicks in to do it. So that's what we're calling afterburn. We've created an oxygen debt. So you've used so much short-term energy so fast that the oxygen consuming system has to kick in to such a high degree for a long period of time to help you recover from it. And so that's what we talk about, the afterburn. He is burning fat because he has to oxidate, and he's breathing a lot of oxygen in because he has to oxidate that fat. And the aerobic system has to be pumping out energy to replenish that. So oxygen is being used to break down the fats that are broken down into the substrates that can be used in another oxygen consuming system to replenish energy. And it's efficient from an energy standpoint, but we were so inefficient for those 9.58 seconds that it has to kick into overdrive to do it. And so we accomplished the same thing with high intensity interval training. That's why your VO2 max can go up similarly by doing Tabata intervals than by doing, what was it, 45 minutes to an hour of steady state aerobic activity. So that's why interval training is pushed to such a high degree. It's very efficient, very, very efficient. But as we work back, there are benefits to steady state that you don't get with the high intensity interval training. So your VO2 max, how you handle oxygen, will go up with that. But now we're talking cardiovascular health, where it comes to just that steady extra beat work of the heart. But also on the cellular level, we talked about mitochondria. They're important for the aerobic system. And you don't have as many mitochondria in your fast twitch fibers as you do in your slow twitch fibers. So at the cellular level, we talked about sugar in the glycolytic being stored. Well, now you're talking about storing fat in the proper places. You're talking about increasing your ability to break down those fatty acids because it's going to store more in the mitochondria to begin with. And you're also going to increase the density of the mitochondria in the cells. So
how does that now, is there any I don't know if there's any literature on this, or if you would just have to guesstimate, how does what you're talking about, how does that compare to what we talked about last time with program density, where you're doing something more intense for 10-ish reps, and then you're going to keep moving with some sort of active rest to let that glycolytic system recover, but overall you're continuing to move. That's one of the things we talked about with program density, is you just got your cardio in because you never stopped moving.
Mm-hmm. Well, and that's okay. So everything is the same except for that mitochondrial density. Now you're still going to get some because you do never stop moving. Let me send one of my workouts over to my computer so I can illustrate this. So what I do, even in my weight training days, I just put my watch on cardio, and it maps. Let's see.
Because that's one of the points of the program density that we talked about last time, is to more efficiently manage your time. Okay,
Mhm.
you're in and out in an hour here. You know, when people ask about cardio, one of the things I do tell them is, uh, if your goal is fat loss, what we talked about, or you've primed the pump. So after you've done strength work, if you have the time and the energy and you're going to do some steady state cardio, now's the time to go do it.
Well, and here's people say, do I need to run more? Do I need to walk more? Do I need here's the thing about cardio. Anything that raises and maintains that elevation of your heart rate is cardio.
Mhm.
And as far as the cellular level stuff, it's going to affect whatever skeletal muscle cells you're using most often in that state.
Yeah. And so then that's my coaching on steady state cardio is it's it's simple. It's simple sounding. It's a little more complicated than this in that find the maximum intensity you can do and maintain for 20 to 30 minutes. Now, if I'm, one of the kids I'm coaching is is a swimmer who's swam competitively since he was in elementary school. So when I tell him that, oh, that's easy. He knows because he's used to uh training a training regimen where they would do part of one of the most interesting parts of swimming training is pacing. They work on pacing so they know what that feels like. So if I tell him that, that's easy for him to do. He can just do it. Now for someone else, you may have to play with that. You may have to tinker with that, of what that pace, what that intensity feels like.
Yeah, and that gets better the more you do it. So when it comes to the weight loss effects, when it comes to the heart rate effect, any activity that raises your heart rate at a consistent rate for a certain amount of time over that aerobic threshold is going to increase that system. And if you're using consistently certain parts of your body when you do it, then at the cellular level, you will get some benefit as well. And let's see if I can bring this up. So here is, and I think this is a decent example. Here is one of mine. This is from March 14th, but you can see my average heart rate was 134. So that for me, that would be, I believe that's zone 3 for me. So it's moderately intense cardio. So, and this is for 50 straight minutes. Yeah, 50 minutes and change. So you can see there's ups and downs because I can't remember what this workout was. What day would March 14th be? March 14th is a Monday. So we got squats. All right. So I was squatting heavier. Whoops. Squatting heavier. So March 14th, that went down a little bit because I was probably taking a longer rest period in between. That, and I'm just now getting back into shape after this. So my rest breaks haven't been the best, but where did that go? Why did we go back to our screen? I am having Zoom difficulties today, probably because I'm trying to think in a complex way while I'm maneuvering,
clicking on things.
Yeah. But again, so cardiovascular goal, I maintained an average heart rate of 134 for, 5/6 of an hour, right? So I'll bring that back up. We're getting a good cardiovascular effect, especially near the end. Now we're getting some high intensity effect. That would have been the leg circuit. So we're going from one exercise to the next, 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 and then not stopping. So you can get a cardiovascular effect from your weight training. Now, steady state is still important because you're going to have a greater effect on the cellular level with that. And stress should be mitigated, right? So we want high stress moments so our body can get better at it. But if we're just trying to add cardiovascular work for volume of it, for maybe that little extra work, you probably want as low intensity as you can. So that's why I'm a big fan of walking. You can get out for a walk, you get into nature, you get a low stress on your body, but yet you still get a little extra cardiovascular effect and it's not a whole lot of calorie burn, but it's more than you did sitting there on the couch watching
Oh yeah.
Netflix. And so put on a podcast in your ears and go for a walk. You're going to multitask there too. But yeah, so benefits to steady state, benefits to high intensity interval training. What is your goal? If your goal is fitness, some of A, some of B, and then eat less. If your goal is fat loss, sorry, it's about nutrition. If you want to work your way to being lean, then you will be injured at some point in your life. I guarantee it. You will have an overuse injury or.
I finally got an extreme example, but it illustrates the point. I finally got around to watching Eddie Strongman, the documentary on Eddie Hall on Netflix, and there's your extreme example of you cannot outwork. Now, they don't have a bad diet, but in order to maintain the fuel that these guys need, he said he eats 10,000 or 8 at this point. This was when he was at top level competition, 10,000 calories a day. That's a lot.
Yeah, he also deadlifts 1,100 pounds.
Yes.
The first person to deadlift a metric ton.
Yep. So there's your extreme example, and they don't look like it. And that documentary is particularly good because when he's at the Arnold competition, you see the strong men and you see the bodybuilders. You know, the bodybuilders, which are in single digit body fat, the strong men aren't.
But here is a good example of energy systems, though, to stay on topic. We brought up Usain Bolt, but when he did the 1,100 pound deadlift, one lift, one picking up of a weight. Now, granted, it took him like 20 seconds to get to the top. It's so heavy, but one lift, and he was breathing heavy in his interview 5-6 minutes later.
Yeah.
And he's still catching it. So he has to eat all that food because that's how much energy they use on one lift. Now they do it 3 hours a day in different lifts. So that's a good testament to the advantage of multi-joint lifts, though. Right. So if strength training burns energy, endurance training burns energy, high intensity interval training burns energy, steady state cardio burns energy, glycolytic weight training, where again you're in the high rep range, burns energy. They all burn energy. Strength training gives you a bigger bang for your lift buck. Steady state has its own benefits, including helping you recover between sets faster for when you do your strength training. So they all burn energy. Some are more efficient than others, but they're all important. So include them all, get a general idea of what your homeostatic state is, including your training, and then eat accordingly. It's that simple, but there was some of the biology behind it.
Yeah. It's not easy, but it's that simple.
Anything else before we switch topics?
No, I think that's a good way to end it.
Okay. Be healthier, everybody. We're going to do part 2, a little wheel of time stuff, which I don't have as much time as I thought we would, but this took longer than I thought we would, but it's an interesting topic. It really is. So, and that's the backdrop. We'll talk more training. And now that we got a little of the biology out of the way, when we bring something up, you can refer your brain back to it. So.